Welcome you all. I am Dr. Jahan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks. Security attacks. Wireless networks are vulnerable to security attacks due to broadcast nature of the transmission medium. Furthermore, wireless sensor networks have an additional vulnerability because nodes are often placed in a hostile or dangerous environment where they are not physically protected. For a large-scale sensor network, it is impractical to monitor and protect each individual sensor from physical or logical attack. Attackers may devise different types of security attacks to make the wireless sensor network system unstable. Based on the capability of the attacker, outsider versus insider node compromise attacks. Outside attacks are defined as attacks from nodes which don't belong to a wireless sensor network. Insider attacks occur when legitimate nodes of a wireless sensor network behave in unintended for unauthorized ways. Passive versus active attack. Passive attacks include eavesdropping on or monitoring packets exchanged within a wireless sensor network. Active attacks involve some modifications of the data stream or the creation of a false stream. Mode class versus laptop class attack. In mode class attacks, an adversary attacks a wireless sensor network by using a few nodes with similar capabilities to the network nodes. In laptop class attacks, an adversary can use more powerful devices, example a laptop, to attack a wireless sensor network. These devices have greater transmission range, processing power, and energy reserves than the network nodes. Attacks on information in transit. In a sensor network, sensor monitor the changes of specific parameters of values and report to the sync according to the requirements. While sending the report, the information in transit may be attacked to provide wrong information to the base station or sinks. The attacks are interruption. Communication link in sensor network becomes lost or unavailable. This operation threatens service availability. The main purpose is to launch denial of service DOS attacks. From the layer specific perspective, this is aimed at all layers. Interception. Sensor network has been compromised by an adversary where the attacker gains unauthorized access to sensor node or data in it. Example of this type of attacks is node capture attacks. This threatens message confidentiality. The main purpose is to eavesdrop on the information carried in the messages. Modification. Unauthorized party not only access the data but also tampers with it. This threatens message integrity. The main purpose is to confuse or mislead the parties involved in the communication protocol. This is usually aimed at the network layer and the application layer because of the richer semantics of these layers. Fabrication. An adversary injects false data and compromises the trustworthiness of information. This threatens message authorities. The main purpose is to confuse or mislead the parties involved in the communication protocol. This operation can also facilitate DOS attacks by flooding the network, replaying existing messages. This operation threatens message freshness. The main purpose of this operation is to confuse or mislead the parties involved in the communication protocol that is not time aware. Cost-based versus network-based. Cost-based attack, it is further broken down into the user compromise. This involves compromising the users of wireless sensor network, example by cheating the users into revealing information such as passwords or keys about the sensor node. Hardware compromise, this involves tampering with the hardware to extract the program code, data and key stored with a sensor node. The attacker might also attempt to load its program in the compromised node. Software compromise. This involves breaking the software running on the sensor node. Chances are the operating system and or the application running in a sensor node are vulnerable to popular exploits such as buffer overflows. Network-based attack. It has two orthogonal perspectives, layer specific compromises and protocol specific compromises. This includes all the attacks on information in transit. Apart from that, it also includes deviating from protocol when the attacker is or becomes an insider of the network and the attacker suppose is not to threaten the service availability, message confidentiality, integrity and authenticities of the network, but to gain an unfair advantage for itself in the usage of the networks. The attacker manifests selfish behavior, behaviors that deviate from the intended functioning of the protocol. Second, layer-wise attacks in wireless sensor network. This session discusses about wireless sensor network layer-wise attack. So, physical layer attacks. This is one of the denial of service attack in which the adversary attempts to disrupt the operation of the network by broadcasting a high energy signal. Jamming attacks in wireless sensor networks, classifying them as constant corrupts packets as they are transmitted. Deceptive sends a constant stream of bytes into the network to make it look like legitimate traffic. Randomly alternates between sleep and jamming to save energy. And reactive transmits a jam signal when it sends traffic. To defend against this attack, use spread spectrum techniques for radio communication. Handling jamming over the MAC layer requires admission control mechanism. Radio interferences. Here, adversary either produces large amounts of interference intermittently or persistently. To handle these issues, use of symmetric key algorithms in which the disclosure of the keys is delayed by some time interval. Tampering or destruction. Given physical access to a node, an attacker can extract sensitive information such as cryptographic keys or other data on the node. One defense to this attack involves tamper-proofing the node's physical package. Self-destructions, tamper-proofing packages. Whenever somebody accesses the sensor nodes physically, the nodes vaporize their memory contents and this prevents any leakage information. Data link layer attacks. Also, continuous channel access excursion. A malicious node disrupts the media access control protocol by continually requesting or transmitting over the channel. This eventually leads a starvation for other nodes in the network with respect to channel access. One of the countermeasures to such an attack is rate limiting to the MAC admission control such that the network can ignore excessive requests, thus preventing the energy drain caused by repeated transmission. A second technique is to use time division multiplexing where each node is allotted a time slot in which it can transmit. This is very much similar to the continuous channel attack. A collision occurs when two nodes attempt to transmit on the same frequency simultaneously. When packets collide, a change will likely occur in the data portion, causing a checksum mismatch at the receiving end. The packet will then be discarded as invalid. A typical defense against collision is the use of error correcting codes, unfairness, repeated application of these excursion or collision based map layer attacks or an abusive use of corporate MAC layer priority mechanism can lead to unfairness. This kind of attack is a partial DOS attack, denial of service, but results in no, marginal performance degradation. Our major defense measure against such attack is the use of small frames so that the individual node sizes the channel for a smaller duration only. 3. Interrogation. Exploits two-way request to send, clear to send can say that many MAC protocol used to legitimate the hidden node problems. An attacker can example an attacker can exhaust a node's resources by repeatedly sending RTS request to send message to clear responses from target and neighbor node. To put a defense against such type of attacks, node can limit its accepting connections from any from same identity or use anti-replay protection and restoring link layer authentications. Civil attack. In this attack, a single node presents multiple identities. All of other nodes is in wireless sensor network. This may lead other nodes and hence routes believed to be disjoint with respect to node that can have the same adversary node. Another of Sybil attack is by using unique SAD symmetry key for each node with the base station. Work network layer attacks, single attacks. Single attacks normally occur when compromised node and send may fake routing information to other nodes in the network with the aim of attracting as many traffic as possible. Hello flood. This attack exploits hello packets or the that are recorded in many protocols to announce nodes to these neighbors. A node receiving such packets may assume that it is in radio range of sender. A loop class advisory can send this kind of packet to all sensor nodes in the network so that they believe the compromised node belongs to their neighbors. This causes a large number of nodes sending packet to the imaginary neighbor and thus into oblivion. Authentication is the same way to such attack. Such attacks can easily be avoided by verifying bidirectionally or a link before taking action based on the confirmation information received by the link. Node capture. Node capture attack is serious attack through which an intruder can perform various operations of the network can easily compromise the entire network. It is one of the hazards attack in violations on network. A single node architecture is sufficient for an attacker to take over the entire network. Selective forwarding black hole attack. In black hole attack, malicious node falsely advertise good path. Example path may be path or most stable path to the destination node during the pathfinding process or in the root table. These intentions of the malicious node could be hinder the path finding process or to intercept all type of packets using sent to the destination not concerned node concern. Malicious or attacking nodes can however reuse to route certain messages and drop them. If they drop all the packets through them, then it is called a black hole attack. However, if they selectively forward the packets, then it is called selective forwarding. To overcome this, multiple recording can be used in combination random selection of path to destination or braided path can be used which represent path which has no common link for which don't have to consecutive common nodes or use implicit acknowledgement from these acknowledgement which ensure that packets are forwarded as they were sent. Wormhole attack. An adversary to tunnel message received in one part of the network over a low latency link and reply them in another part of the networks. This is usually done with the confirmation of two adversary nodes, where the nodes try to understand their distance from each other by broadcasting packets along an out of bound channel available only to the attacker. To overcome this, the traffic is used to the base station along a path which is always geographically shortest to the use to the graphically shortest or use very tight time synchronization among these nodes, which is infeasible practical. After the message efficient encryption and authentication techniques can be defined spoofing attacks, misdirections, homing, Misdirection. This is more active attack when malicious not present in the routing path can send the packets in wrong direction through with the destination is unreachable. In place of sending the packets in correct direction, the attacker misdirects those and though that towards one node and thus this node may be victimized. In a homing attack, the attacker looks at network traffic to reduce the geographic location or critical nodes, such as cluster heads or neighbors of the host station. The attacker can be then physically disable the nodes. This leads to another type of recall attack. Transfer layer attack flooding. Sometimes malicious node can cause immense traffic or useless messages on the network. This is known as flooding. Sometimes malicious node replays some actual broadcast messages and hence generating useless traffic on the network. This can cause cognition and then eventually lead to exclusion of complete nodes. This is form of denial of service. Desynchronization attack. In this attack, adversary repeatedly forges messages to one or both endpoints which requires transmission of mission frame. Hence, these messages are again transmitted and if the adversary maintains a proper timing, it can prevent and endpoints from exchanging any useful information. And application layer attacks, overall attacks. An attacker while attempt to overall network with senior stimuli, causing the network to forward large volumes to traffic to a base station. This attack consumes network bandwidth and trains. It involves injecting spurious or replayed packets into the network at leaf node. This attack can starve the network of legitimate traffic because it consumes resources on the path to the base station, thus preventing other nodes from sending data to the base station. Deluge attack. The network programming system let you remotely reprogram nodes in deployed networks. If the reprogramming package is not secure, an intruder can hijack this process and take control of large portion of the network. It can use authentication systems to secure the reprogramming process.